Hi guys, this is Alex Crooks from Virtual Robotics Toolkit from Cognition Robotics, and we're testing out using Facebook Live for doing live lessons. So I was going to show you guys a new addition to the software. So we've been making a couple of custom robots for some of the lessons, some of the challenges in here. And so this is the basic knock down the bricks challenge that we have. If you're not familiar with it, all that you have to do is the objective is to get the robot to knock all of these blocks right here off of the table. So the first thing that you need to know when you're using the Virtual Robotics Toolkit is how to communicate with the robot. So there are two different ways to do that. The first way is you can just hit the play button here, right? And then you can just press W, A, S, and D in order to drive the robot around. You can drive it like a remote control car or something like that. So that's one way you can use it. And you can kind of practice out your idea to see how that works for you. But that's not the most powerful way to use the simulator. So what is more powerful is to use it as an actual tool to program the same way that you would a physical robot. So in order to do that, I'm going to stop the simulator by hitting the stop button right here. And then I'm just going to go to here and open up the virtual brick, and it works just like a physical brick does. So if you're familiar with that, you're familiar with this. So in order to turn it on, you just hit the center dark button right here. There we go. And unlike the physical one, it boots up quite quickly. If you're curious, I'm in my makerspace today in North Carolina. So you may hear saws and things in the background as people are building things. But hopefully it won't be too distracting. But all right, so now that the robot is on, I can connect to the robot in the actual programming environment here. So I'm going to bring that up large scale. So when you first open the programming environment, you have this, and if you're not familiar, you just hit the plus right there in order to open a new file. So I'm going to open a new file there. There we go. Okay, so if I need to connect to that robot, so this is the same programming environment that you use for the physical one, so you connect to it in the same way. So I go down to this third tab down here, and there's the sweeper bot. So I just click on it, and what we've done is the software kind of fakes out the Lego programming environment to make it think that it's a Wi-Fi robot, where in reality it's a simulator. But this piece of software can't tell the difference between a physical robot and our simulator. So that's pretty cool. All right, so then all I have to do, I'm just switching back and forth so you can see. So I know that I want to drive forward a little bit, and then maybe I'll take a left turn here. So I'm going to try a drive forward. So I'm going to grab a move steering block down here, and I'm going to just sort of guess maybe at 3 rotations. I'm going to test that out. So there's a lot of different ways that you can test it out. But I'm going to do what I tell my students not to do, which is I'm going to click the download and run button, which you really shouldn't do. But it's a bad practice. But I'm gonna cheat here and do that. All right, so download and run, and then I come over. There's that. Okay, so 3 rotations was a little bit too far. Looks like I might need to go maybe 2.5, something like that. All right, so I'm going to go back and change my software. Let's try 2 rotations instead and see where that takes me. Now, in real life, I'd have to go and pick this robot up and bring it back and place everything back. But all I have to do is hit the stop button. That's it. And it resets everything. So let's run it again with 2 rotations and see where we are this time. That's pretty good. So I'm going to do 2 rotations. I'm going to take a left turn and then drive through and see if I can push those off the table there. All right. So there's that. Here's my left turn. I'm going to guess 0.7 rotations. It's just, I'm purely guessing. Oh, no, we got hammering going on now. That's really loud. I'm sorry about that. All All right, so I'm going to do a left turn 4.7, and then I'm going to do a drive forward. Let's see if this knocks our blocks down, or if I at least contact them. So let's take a look here, see what's going on. All right, I'm going to reset the robot. There we go. And now I'm going to... And a message from Chris there that this guy's hammering. I'm not at work right now. This is my makerspace, so I jumped on to test this today. Sorry, Chris, you're gonna have to deal with the hammering. Okay, download and run, and there's the forward. There's the left turn. Whoa, too much left turn. So I need less left turn than that. So I'm gonna reset. Come back here. Less left turn than that. So let's try 0.4. 0.4, there we go. All right, and I will run it again. There we go. Left turn, contacted the blocks. All right, so that's pretty good. I've knocked them over, which is one of the objectives. Now, the idea of this is that you may start off with this. Let's go ahead and do this. Let's say 4 rotations to get most of them off the board, but they're going to kind of fall, spread a little bit. So we're going to have to use some sensors eventually in order to get the rest of them to get knocked off. All this autonomously, of course. All right, so let's see if we have knocked some off like this. I don't know what they're building back there. I'm sure it's something cool. All right, here we go. All right. So that's almost all the blocks. I've got this one left. So how would I find it? So I'm going to take over with WASD and show you something. So I have a couple of sensors on this robot. I have an ultrasonic sensor mounted really low down here that's between these two right here so that it can see objects that are really pretty far down. And I also have a couple of light sensors here that look at the matte color. But for right now, I'm going to talk about the ultrasonic sensor. So we have visualizers in the software, which is something that you don't have in real life, but it kind of lets you see whether the sensor is seeing something close or far away, that kind of thing. It just helps you get an idea of what your robot's seeing. So blue is basically it's seeing maximum distance, it's not seeing anything. Yellow is intermediate, and then orange, red are close objects. So we could use that sensor in order to figure out where a loose object is. And I'm going to show you a quick algorithm for that. Let's see. So what I want to do, anytime that you're doing something autonomously with a sensor, you're probably going to be using a loop. So I'm going to grab a loop here, and I am going to put a switch in it for making decisions. So the easiest way to make decisions in this software is with a switch. There are other ways you can use the sensor itself and use that data mathematically, which is a little bit more advanced version of doing the same thing. But so I need to change it from a touch sensor to a different kind of sensor. So I'm just going to click there. And then I'm going to go over to ultrasonic sensor and click compare. Distance in centimeters. We're going to be metric since Cognition Robotics is from Canada. So thanks for being metric. I have a window within a window for EV3. Yeah, I know. It's so that when I switch back over to the when I switch back over to the main program, you can still see the programming if you were curious. That's why I left that up there, so that when I switch to this, you still have the window that you want to see, so that way it won't go away. Okay. It's not blocking, is it? It could be blocking. Anyway, so what I'm going to say is if I see an object that's less than 50 centimeters away, so that we're going to call that close. So if something's close, it's going to do what goes here. And if something's not close, it's going to do whatever is here. So if there's something close, I want the robot to push that object, right? So I'm going to say if there's something close, I'm just going to put this little block up here, and I'm going to turn the motor on permanently. So it will go forward as long as this is true. It'll go around and around and around in this loop right here. If there is not something close, I want it to look for something close. So I'm going to do the same thing. I'm going to turn the motor on, but instead of having it go straight, I'm going to have it turn around in circles, and I'm going to slow these circles down quite a bit there. Okay, so let's run this. So I'm going to start it all over again, and I'm going to run it here. All right, download and run. There we go. All right, so I contacted a group of them. There we go. Oh. I almost fell off the edge. Did I fall off the edge? Oh, I fell too far off the edge. I need to make that that first drive here. Let's call it 3.5 instead of 4, so that we don't go quite as far. I'm going to reset everything and try again. I'm glad I don't have to pick those blocks up and put them back down again. That would take a while. There we go. All right, so there goes the robot, and it's going to push the blocks. It got most of them off, but I fell off again. I'm going to have to make it 3. I can use my sensors to do that, to stop for me, but I'm not quite there yet, so I'm going to do it with just these numbers here. There we go. Okay, I don't want to turn off the robot. All right, one more time, and we're only going to go forward 3 rotations this time. So forward, turn left, drive and push. There we go. I got a few of the objects, and then I started turning, and I fell off again. All right. Let's see if I can solve this by turning even less. All right. Stop. All right. And we're going to run the software again. There we go. Turn left. Drive. Okay. Oh, I get it. It's a robot. It's doing exactly what I told it to do. So it was seeing objects in front of it, so it keeps pushing them until it's pushing them right off the edge. That's the thing about robots is many times the error is between the keyboard and the seat, as they say. The robot was doing what I was telling it to do. So it was pushing them off, but the problem was that it didn't have any instructions on how to stop. So I need to tell the robot how to stop as well, which I'll go over in a different video. But I'll tell you what, I'm going to show you the algorithm running by itself. So I will WASD this to get a good position here. There we go. All right, now I'm going to run just that section of code here that I was introducing. There we go. All right, so you see it's turning until it sees an object, and then it pushes it off, but then it's going to fall over the edge because I don't have any way of detecting. So in a future session here, maybe when there's less hammering in the background, I will show you guys how to use a light sensor to prevent that robot from ever falling off the edge like that, which is pretty cool. So until then, I will see you next time. Thanks a lot.